Hey gang, welcome back. We are doing an exam review problem. This is for exam 2, okay? Now if you're doing this, stop what you're doing, push pause. You should be able to work this, and then come back to the video and then watch me and I'll tell you what the solution is, okay? Ready, set, go, push pause. Okay, are you back? All right, here we go. I'm gonna solve this problem, okay? So what do we have? We have a built-up beam, right? It's made out of 2 boards that are nailed to one in the center here, okay? We've got our dimensions for the cross section over there. And then we've got, this is that beam right here, is this guy right here, okay? And he's got this distributed load, and it's got a concentrated load. And let's see what the question is. Each nail can resist 2 kilonewtons of shear force, right? That's these nails here, boom and boom, okay? S is the spacing of the nails, 120 millimeters. So from here to the next nail, to the next nail, to the next nail, 120 millimeters between the nails, okay? The allowable shear stress of the beam is 3 megapascals. Now what does that mean? I don't know what that means. Hold on a minute. Find the maximum P, okay? So there's 2 things that can limit P, okay? The 2 things are, number 1, can the wood itself just hold the thing, right? Does the wood have the strength to hold the load, okay? So I should be able to find a P using this 3 megapascals as like the limiting factor. And then thing number 2 is, can the nails physically hold the load? So who's going to be doing the limiting here, the wood or the nails? And I got to test both things, and I'm going to find a P for the nails, I'm going to find a P for just the wood, and then I'm going to have to choose one of those as being the answer. Which one am I going to choose? The smallest one, right? The smallest P, because the biggest P is going to make the other one fail, right? So I'm going to find a P for both scenarios. So I'm going to work this problem 2 different ways, because I got to test, will the wood fail or will the nails fail, right? And so, and then I got to test and see which one has the smallest P, and that's going to be my answer, okay? Most students would only do one of these and just wouldn't even check the other one, and then they would never know if I had the right answer or not, but we're going to do it. Here we go, okay? So the first thing we're going to do, okay, now one of the things that I like to do here is kind of sketch myself a little V diagram, okay? Because here's what I've got, you know? I've got a distributed load, and it's this big, right? It's 2 times 1.5, that's 3 kilonewtons, okay? And so what is the force over here, right? Let's call it AY, at the origin of that beam, right? At the wall. What is the wall having to do there, okay? As far as shear force goes. Well, it has to resist this and that, right? So AY is 3 plus P, yeah? So my shear diagram would look like this. I have to go up 3 plus P, right there, 3 plus P, and then no change, no change, no change, bam, right? And then do what? Go down 3, whoop, there I am going down 3, okay? And then over at the end, I gotta go down P, back to 0, okay? So there is my V diagram, okay? So V max on this beam is 3 plus P. Now that's in, let's do this. That's in kilonewtons, isn't it? That's kilonewtons. Stone cold kilonewtons, okay? We'll do 3,000 newtons plus P, okay? Is that cool? That's V max, okay? Now I'm gonna need V whenever I do, I don't know, maybe some VQ over IT here in a second, maybe, okay? I think I'm gonna need I, okay? And in order to find I think I'm going to need to know where the heck, right, is the neutral axis, which means I gotta find the centroid of this thing, don't I? I've got to find Y bar, okay? Let's just do that right quick, okay? Let's find out where that is. Okay, let's do this. Piece number 1, piece number 2 in the middle there, and then piece number 3 over here. Okay, here we go, Y bar. We got 1, 2, 3 pieces, YA and YA. Remember how to do this? Oh, do we know how to do this or what? Okay. Y bar for piece number 1. This whole side panel over here is 200 millimeters high. So y bar is 100. The area is 200 times 20. That's a 4 with 1, 2, 3 zeros. Okay. Y bar of piece number 3 is going to be exactly the same, isn't it? 100, 4,000. And then this number is going to be 4,000 with 2 more zeros on it, right? 1, 2 more zeros. So 400,000. Okay. And then what is y bar of piece number 2 there in the middle? I don't know. It's 200, and then come back half of that thickness, which is, that thickness is 40. So 200 minus 20 is, what, 180? Okay. And let's see, the area of that guy is 40 times 200, which 4 times 2 is 8 with 3 zeros. Okay. And then I can't do that one in my head. I probably can, but I'm not going to. Okay, here we go. 8,000 times 180 is 101,440,000. 1,440,000 plus 800,000 equals 2.24. 2,240,000. Okay. And then let's see, 8,000 plus 8,000, that's 16,000. So y bar is equal to 2,240,000 divided by 16,000, which is equal to, divided by 16,000, 140. Okay. So the centroid, the neutral axis, is 140 millimeters from the bottom of the part, 140 mm's. Okay. I needed that, didn't I? Because I need that to calculate I. Okay. Do you think we can calculate I? How many pins do you need to have open at a time here, buddy? Okay. Let's go. Okay. Do you remember how to do this? Parallel axis theorem, right? So piece number, let's do this. We'll do a Tudums. Did you learn your Tudums in school? Tudums? Like Tudums 2 is 4 and Tudums 3 is 6? Nobody learned your Tudums? Okay, because I'm going to do piece number 1 and 3 at the same time since they're the same. So 1/12, the base, it's all about that 20 times the height, 200 cubed, plus the area, I got the area at 4,000, times d squared. Okay, what is d? Remember, d is the distance from the centroid of each part, which will be 100, off of the 140. So 140 minus 100 leaves me with 40. That trick works every time, right? Remember that? Take the centroid, subtract the centroid of the piece part from it, boom, you get the distance d every time, okay? That's pieces number 1 and 3, right? Now we got to do piece number 2 up there, so plus, piece number 2 comes in like this, 1/12. The base is 200. The height is 40. Plus the area, we got the area piece number 2. Yes, it's 8,000. Okay, and then what is D? What is D? Okay, let's see. D is what? 140 minus 180. It's still 40, isn't it? Okay. But you should have put negative right there. But I'm squaring it, so it's all good, right? All right, now you better put this in your calculator twice to make sure you get the right answer, because this is easy to mess up, isn't it? 20 times 200 cubed equals, divided by 12 equals, okay, and then plus 4,000 times 40 squared equals, that's a number there, times 2 equals, oh goodness, so this top part up here, I got 3, 9, 4, 6, 6, 6, 6, 6.7. Whoa, that's a lot. Okay, 39 million, is that right? Yeah. Okay. And then the bottom number here, what are we going to add to that? We're going to add, let's see, 200 times 40 cubed divided by 12 equals plus 8,000 times 40 times 40. Okay. Equals, okay, I got a number here, 138, 1, 2, 3, 4, 5, 6's, 0.7. Okay, so add those two together, boop, and I got I, right? So plus 39,466,666.7 equals 5, 3, 3, 3, 3, 3, 3. There's a lot of threes. How many threes is that? 1, 2, 3, 4, 5, 6, 7 threes. 1, 2, 3, 4, 5, 6, 7 threes. 0.3. Okay. There you go. 53 million. Now what units is on that? Right? Now when you do millimeters, right? When you do millimeters, some of y'all are afraid to calculate millimeters because you get giant numbers. But you know what? My calculator is not scared of big numbers, okay? This is to the 4th power, okay? Millimeters to the 4th. So that right there is I. Boom, okay? Equals I, okay? Now I'm going to use that same I for every equation, whether I'm going to use VQ over I or VQ over IT, same I, okay? So I'm going to use that a lot. So I'm going to erase this other bit up here just because it's kind of in the way now. Okay, I hope you followed that. That's way back from statics land there, right? Calculating I. We know how to do that real good, don't we? Okay. Now that I have that, let's calculate one more thing, and that is, because here's what I'm doing, right? I'm testing scenario number one. Scenario number one in my mind is, will the wood fail? Okay, and the wood failing is this: tau equals tau max, right, equals VQ over IT, okay? Where is the absolute biggest shear stress? Where does it occur? Do you remember? Always at the neutral axis. So the biggest shear stress is going to occur here at the neutral axis, okay? Because that's when Q is as big as it can possibly be, okay? So what do I have here that goes in this equation, okay? I've got tau, right? I'm going to use this 3 megapascals over here, right? So that's going to be 3, and I'm going to put newtons over millimeters squared. Remember that trick. Is equal to V. Do I know V? Yes, it's right here. 3,000 newtons plus P. There's V. And so I need Q, don't I? Let's calculate Q. Do you think you can do it? Now here's the deal. On Q, when it's about the neutral axis, you can either do what's above the neutral axis or you can do what's below the neutral axis. You'll get the exact same thing, okay? I think I'm going to do what's below the neutral axis, okay? Because I think that's easier, okay? So below the neutral axis is this right here. Is this little tail right there. And there's the centroid of that little tail right there. And whatever I get, I'm going to multiply it by 2 because I got one there and I got one there, yeah? Okay? So here I go, Q, and I'm just going to put Q in A. Q about the neutral axis, right? Or I could put Q max if I wanted to, is this. Q is area, and the area of that is what? It's 140, that's where the neutral axis is, right? Times 20, okay? That's the area right there, okay? And it's the area times y bar of that area. So from the neutral axis to there is how far? Well, the whole thing's 140, so half of that, it's 70, isn't it? Okay? So that's going to give me Q. Okay, here we go. Q max is, clear, what's happening here? 140 times 20 times 70 is 196,000, okay? 196,000 millimeters cubed, okay? There's that number. Right? This isn't hard, but just getting all these numbers to put in my equation is hard. 196,000, millimeters cubed. Okay? Divided by I got it. 53. 1, 2, 3, 4, 5, 6. Okay? That's millimeters to the fourth. And then times T. The thickness that I'm going to have to shear through, that I'm going to have to tear through at the neutral axis to make that beam shear in half, transverse shear, right? What am I going to have to tear through? I got to tear through that, and I got to tear through that, right? 20 there, 20 there. So I got to tear through 40 millimeters, okay? So boom, what do I got here? Okay, I got an equation with one thing in it, right? And that is P, okay? And P is going to be in what? My answer for P here is going to be in newtons, isn't it? Okay? Oh, I don't know if we can do this or not. Let's see. 3 times, I'm multiplying all this bottom stuff, right? Times 40 times 53, 1, 2, 3, 1, 2, 3, 0.3 equals divided by 196, 1, 2, 3, okay, equals. So now I have 3,000 plus P is equal to, this number I have in my calculator here, 32,653.06. Okay, so P is equal to minus 3,000. Okay, 29,653.1 newtons, or, right, 29.7 kilonewtons, okay? Stone cold kilonewtons. That's one of my answers, okay? That is one of my answers. So P, for just the wood being in control, the wood can take 29.7 kilonewtons for P, okay? 29.7 kilonewtons, okay? That's what the wood can take, okay? Are you with me? That's step one. Wow, that's a lot, okay? Now I'm going to erase this. Now I'm going to go back and do step 2, and that is check, see how much the nails can hold, okay? So let's go. Okay, this out of the way. Okay, the equations for the nails. Okay, this is built up members. Remember this? So I have this. I have little q equals VQ over I. Okay, that's shear flow. Or little q equals F divided by S. F is the shear force of the nails. Okay, divided by S is the spacing. Okay, now the shear force of the nails I know, don't I? Okay. The shear force is given over here as 2 kilonewtons for each nail. But when I have to tear, when I'm going to make that middle board there, right? I've got to make this board tear out, right? To make that beam fail, to make those nails fail, okay? But I got to tear through 2 of those, right? So I've got to put a 2 right there, okay? So I've got this, 2 times what? 2 kilonewtons? So I'm going to put all this in just newtons so that I don't mess that up, okay? Divided by the spacing, which is 120 millimeters, okay? So little q is 4,000 divided by 120. And that is 33.33, okay? 33.33. And the units on that, newtons per millimeter, okay? So that's little q. Now I'm going to take that little q and set it equal to that guy right there, right? So 33.33 newtons per millimeter is equal to V. I know V, okay? 3,000, also newtons, same units, right? Plus P, there you go, times Q. Okay, now Q is not this Q, okay? This is Q max. But if I just want to tear away that board, I need Q of that area there, that board that I'm going to tear away, right? Totally different Q, okay? Let's put a dot right in the middle of that area. There it is, right? So what is that Q going to be? Because that was Q neutral axis that we calculated before. This is different Q, okay? So Q, TB, what's TB? top board, okay? Q for the top board, okay? Is going to be equal to the area of that top board is what? 40 times 200, okay? Times Y bar. So how far is it from here to the centroid of that? Well, if this is 140 and that whole thing is 200, then this must be 60, right? Right here, from the neutral axis to the top. So I go up 60 and then I come back half of this 40, right? Go up 60, come back half of 40, which is 20. It leaves me with 40, doesn't it? It's at 40. Okay? So Q for top board is 40 times 200 is 320,000. Okay? And again, that's millimeters cubed. Okay, so V, Q, 320,000 millimeters cubed divided by I. Oh, guess what? Same I. 53 million. 333 millimeters to the fourth. All right, here we go. So 33.33 times 53. 1, 2, 3, 4, 5, 6.3. And then divided by answer 320,000 equals 54.9999. Let's call it 55, huh? Yeah, let's do that. Newtons, okay, equals 3,000 newtons plus P. So P is equal to 55 minus 3,000. I can't believe I put that in my calculator. 2555 newtons, or 2.56 kilonewtons, okay? So, all right, what is the answer, gang? What is the answer to this problem? Okay, the wood can take P being 29.7 if this thing was like solid wood, but the nails can only take 2.56 kilonewtons for P. That's as big as P can be, okay? So this right here, that's our answer, okay? But you needed to go back and check that, because is that always true that that's going to be bigger? Nope, not always. If those nails would have been closer together, that probably wouldn't have been true, okay? All right, that's a good problem for the test right there. Let's go, team. Okay, hope that helped.